Hi all. Today we are going to understand how we can design a logic gate, that is AND gate, using a simple neural network. So let's see how we can do this. So understand this concept very clearly because when you go to the interviews for the companies like Qualcomm or Nvidia where you have to merge your AI models or where you have to merge your AI knowledge with the digital electronic part, that is hardware, these concepts can come very handy. So this is one of the question which was asked to me for my interview in Qualcomm. So let's understand how it is done. Now let's understand what a simple AND gate looks like. This is how the AND gate is, where we have two inputs, that is x1 and x2, and we have a output y. What this AND operation does is, it does the multiplication of these two inputs and give us the output. Now here we have taken inputs as 2, so here basically we will have 4 combinations, which will be nothing but 0 0, then 0 1, 1 0, and then 1 1. So when 0 0, the output will be obviously 0 multiplied by 0 should be 0. Anything multiplied by 0, 0 1 is 0. 1 0 is 1, but when 1 1, we get output as 1. So this is how a truth table for a AND gate looks like. Now here we can see we call AND gate as a linearly separable function or a linear model because here we know only for one condition we are getting output as 1 and for rest of them we are getting it as 0. So this we can model easily linearly. If we have output 1 more than once, then it is not a linear model. That means we need some two or more conditions to get the output as 1 for the given logic gate. So let's see now how we can design it using a neural network. There is something called perceptron in a neural network part. What it is type of a simple ANN. Okay, let me write it down basically. So this is perceptron. Please spare my handwriting. I'm trying my best to write it in a good way, but yeah. So this is nothing but a simplest form of artificial neural network, okay, where we have just two inputs and one output. So for perceptron with the two inputs and one output, we have two inputs here and one output. How is the output formulated here? This output will be 1 if now here we write some condition or 0. Okay. Now we know that for neural network, for a linear model, the simple equation is like y equals to mx plus c, correct? But for neural network, our m is nothing but weights that will be replaced by w and c will work as a bias. So this is a simple formula for linear models that is nothing but y equals to wx plus b. Now as the number of inputs vary, we vary this x1 plus say x2 w2 and so on till we have say n inputs. Then we can write it as wn and then plus b. Okay, so remember this for multiple inputs, we can extend this formula as I have written here. So this is a simple maths. Now we have this simple formula. Now for my output to be 1, these two inputs should be 1, then only my output is 1. Now first let's write a general formula for perceptron with the two inputs and outputs. Now here we will get 1 if and only if, here we have how many inputs? Two inputs, correct? So just write it. X1 W1 plus X2 W2 plus my bias when this is greater than 0. When the value of this equation is greater than 0, then only we will get output as 1, otherwise 0 for all conditions. Now, whenever we design a neural network, we have to see this condition is satisfied. Always we have to satisfy this condition, then only we'll be able to define a neural network for this. So we have to see this condition is always satisfied whenever we need to design a perceptron based model or a simple neural network. Now let's write this table again. So here the goal is only when both inputs are 1, then only my output should be 1, otherwise 0. Okay, so my equation setup, how it will be? Let me write my equation setup. This will be like my output equals to 1 if my equation, what was that? X1 W1 plus X2 W2 plus B is greater than 0. Now this I have to follow. Okay, so write once again, let's write this table. I have, and here in between I am adding sum where we will be writing the sum of all these outputs. We'll be calculating and given, and then we have this output. Okay, let me just make it little bit cleaner as much as I can. Now let's start. For now, we know these two inputs x1 and x2 will be getting from the truth table. Okay. But we need to set some values to W1, W2 and bias which follows this condition to get my output as 1. How we will do that? We will assume some values for W1, W2 and bias and then we'll check for different values. Say now we will directly go to the solution here. If I set my W1 to be 1, my W2 also to be 1 and if my bias is minus 1.5. Now here we have the inputs 0 and 0. Now okay, put this equation's values to this. Now what my equation will become? This equation, when I put all the values, it will become like x1 w1 is 1 plus x2 w2 is 1 minus 1.5 should be greater than 0. So my output should follow this condition to get the result as 1. Now here it is 0, 0. So what will be my sum? X1 is 0. This 0 plus this is nothing but minus 1.5. Correct? Minus 1.5. This is less than 0, so my output will be 0. Next is 0, 1. Put these values in this equation. Here in this equation, if I put it, here it is 0 plus 1 minus 1.5. So basically it will be minus zero point 0.5. Again, this is less than 0. Output is 0. Now here I have 1, 0. Put it again, you will get again minus zero point 0.5. This is less than 0. You will get output as 0. Then we have 1, 1. Put it here, 1 plus 1, this is 2. 2 minus 1.5, so what we will get here is plus zero point 0.5. This is greater than 0, so my output becomes 1. For this conditions where I am setting W1 as 1, W2 as 1 and B as minus 1.5, I am getting my truth table for the AND logic gate in the form of a neural network type. So this is how I can develop or design my neural network for this AND logic gate. So let's just see a simple diagram how it will look like. Say this is my neuron. To that my one input is x1, my another input is x2. This is my weight 1 which I have given as 1. This is my weight 2 which also I have given as 1. Here it will be a bias which is nothing but I have given it as minus 1.5 and this will be my output which will be 1 if my condition satisfy, 0 otherwise. So yeah, this is how you can design a AND logic gate using a simple neural network or perceptron here. I hope these concepts are fine. You can try and write a code for this. We'll see how the code is implemented or how we can write a code to develop or design this AND logic gate using a neural network. So this is how you can develop for OR gate, NOT gate, XOR gate or any gate using a simple logic or simple truth table as your concept and then getting some equation set up and then setting some weights and biases values, then calculating the parameter according to the output. I hope this was interesting for you guys. If you like this video, please subscribe my channel and keep sharing the content. Thank you.